Hi friends, today I am going to tell you about light emitting diode and the LED characteristics. First of all, my name is Chandu Led and this is writing class 1193. And the definition of first of all we see the definition of LED. A light emitting diode is a semiconductor device that emits visible light when an electric current passes through it. This is the brief history of LED. In 1997 it was first discovered and later it was developed a lot. We can see in this from 2009 up to 2009 it was developed. And the development stages we are seeing right now, we are studying the development stages, various development stages. And it was developed a lot by many scientists. And how does it work? When an electric current passes through the p-n junction diodes, the light is emitted through the recombination of the electrons and holes. And these are the electrical characteristics we are going to see in p-n junction diodes and also LEDs. Here the important threshold voltage and also the current are the major factors here we are going to see. And this one of the electrical properties, the heterojunction is a very important property to reduce carrier losses in LEDs, light emitting diodes. And we can see the heterojunctions, how this is going to process in various materials we are going to see by the picture. LED properties and the carrier loss, as we told, family level and all those the important components. And blocking layers, there was a blocking layers for different materials where we can produce this. As the optical property is also is the important property in LED. Coming to here, their efficiency is internal and external efficiency, and these are the electrical properties: emission spectrum, that's a light escape cone, and that's the emission spectrum in a Lambertson emission law. Temperature dependence of emission intensity. Temperature decreases with increasing temperature, causes include non-radiative recombination in a heterostructure barriers. We are going to see that also. In a heat in LED, this is the major part we are discussing here, and the heat is produced within the LED device itself due to the inefficiency of the semiconductor process that generate light. So we have to how to reduce it, how are the process we are going to see. First of all, heat generation. We see the basic fundamentals of this heat transfer. The fundamentals of heat transfer: conduction, convection, and radiation. First of all, what is meant by conduction? Conduction is the transfer of heat through a solid material by direct contact. This is the first mode of heat transfer to get the thermal power from the LED junction to the heat sink. Metals are typically the best conductors of heat we are going to see in LEDs. And the convection is the transfer of heat through the momentum of fluids and gases in LED system. This is typically the transfer of heat from the heats into the ambient air. Here are the convections we are going to see, and this is the radiation. Radiation, the transfer of thermal energy through an electric field and the torque. But these are the majorly three parts where the heat is transferred, and the thermal path of model is illustrated by a simple resistor system. The notations for the system. And this one is the heat thermal stack. This is the ways we control the heat. And this one, PCB heatsink, are the important parts where we can reduce the heat in LEDs to maximum extent. And the fans and active cooling are the important things we can reduce the heat. Is the can these are all the theory part we have covered. The thermal, can we take the heat is the changing the materials, we can change the heat to maximum extent. Advantages of using LEDs. LEDs are more far away from many other bulbs and all types, because LEDs have greater advantage than others. The main disadvantage coming to it is it's currently more expensive. Oh, and also the heat produced in it. The applications in it: sensor applications, mobile applications, sign applications, automatic uses, and LED signals. Here we can have many applications. And the summary is we can see the different parts I have mentioned, how we can improve the management. Proper thermal management is the only way to improve the LED. Here's the references I have used, and thank you to one and all.